Okay, so in this lesson, we're going to be talking about quadratic functions. So we're going to be looking at the different parts of a parabola, which is a quadratic. So graphs of quadratic functions are parabolas that open up or down. The vertex of the parabola is the maximum, which opens down, or minimum value, which opens up of the function. So right here, this is our vertex. The max or min of the parabola is located at the vertex. The axis of symmetry, so remember, symmetry means it cuts it into two equal parts. So the axis of symmetry is a vertical line that passes through the vertex point. So it cuts the parabola into two equal parts. That's called axis of symmetry. So it says determine the direction of the opening of the parabola by looking at the value of a. So on a quadratic function, it's ax squared plus bx plus c. And then on your function, it's f of x. So f of x equals. So a is always your coefficient of your x squared. So if a, this is standard form. So if a is a positive, so if the quadratic term's coefficient is positive, it will open up. If it is negative, it will open down. And then the y-intercept is located where the parabola intersects the y-axis. So we're going to be finding a couple of things on your parabola. So we're given this graph. We want to find the vertex point. So notice that point is 1, 2, 3, 4, 5. And then you're determining if it's a max or a min. It's max because it's at the top of the parabola. So if it's at the top, that is a max, which should make sense. If the vertex is at the bottom, that is a min. Okay, so this is a maximum point at 2, 5. Your axis of symmetry is always x equals, always. It's where it crosses the x axis. So it crosses the x at 2. So it would be x equals 2. And then the y-intercept is at 0, 1. The direction of the opening of the parabola, it's opening down. So if we were to look at the actual function, a would be negative because it's opening down. So those are a couple of things that we're going to be looking at on a parabola, which is a quadratic. So example 1, we're going to complete the chart identifying the attributes of the graphed function. First thing, we're going to find the vertex. 1, 2, 3, 4, 1, 2. So your vertex would be 4, negative 3. Notice your vertex is at the bottom of the parabola, so that's a minimum. And it is at that vertex point. The axis of symmetry is that straight dotted vertical line that goes through the vertex, which cuts it into two equal parts. It's always x equals wherever it's crossing the x-axis, which is also the x value of your vertex. So x equals 4. The y-intercept, it crosses the y at 5, so 0, 5 would be your point. And this one is opening up. So the function would have an a value that is positive. Okay, let's take it back. Now, there's the standard form that I was talking about on the front, but there's also vertex form. So there's a couple of forms that we can see in a quadratic. So standard form, and then there's your vertex form. So quadratic functions may be written in standard or vertex form. So to find your vertex in standard form, if you're given the equation, there's a formula. Negative b over 2a will give you the x value of the vertex, and then you will just plug in that x value to find the y value of the vertex. Okay, looking at your vertex form, it says h and k are the x's and y values of your vertex. So notice that on this vertex form it says x minus h, so h is always the opposite of what you see in the parentheses. K is exactly what you see. Okay, so let's look at example 2. We're going to identify the vertex, maximum or minimum, axis of symmetry, y-intercept, and the direction of the opening. So I'll go ahead and just write all that down. Vertex. So when it's in standard form, to find the vertex, you're going to find the x value by plugging into the formula negative b over 2a. So this is your A term, this is your B term, and this is your C term. The C term is actually your y-intercept. So if it's in standard form, C is your y-intercept. So I'm going to plug in. Notice B on the formula is negative, but B is -6. So that will make it +6 over 2 times A, which is 3. So that would be 6 over 6, which equals 1. So there's the x value of your vertex. Now, a lot of students stop here because they forget how to find the y. Anytime I know an x value, I'm just going to plug it in to my function to find the y value. So that's what I'm going to do next. So I'm replacing all of my x's with a 1. So that would be 3 minus 6 plus 1, so -3 plus 1, which is a -2. So there's your y value of the vertex. Next thing I need to find, is it a max or a min? So you're looking to determine if it's a max or a min based on the A. So notice A is positive, so it will be opening up. So if A is positive, it opens up. So our vertex is at the bottom. So this is a min at 1, -2. Okay, so we want to find the axis of symmetry. So remember, the axis of symmetry always starts with x equals, and it's always crossing through your vertex point. So whatever your x value of your vertex is where it crosses the x-axis. So x equals 1. Your y-intercept is where it crosses the y. If it's in standard form, it is your c value, so 0, 1. And then the direction, it opens up because our A is positive. All right, let's take a look at part B. Notice this is not in standard form. This one is in vertex form. So to find the vertex with vertex form, remember your vertex is HK. Remember, H is the opposite of what you're seeing. So instead of it being negative, it's +1. So that's a common mistake. Make sure you do the opposite of H. K is exactly what you see. So K is your y value of the vertex. So our vertex point would be 1, 9. Looking at your A, because if you look at your A is what's in front. Notice it's negative, so the direction of our graph would be opening down. So that means our vertex point would be a max up at the top. So max at 1, 9. And then our axis of symmetry, remember, is always a straight vertical line. It's always x equals, and you always cross the vertex, which crosses through the x-axis at 1. So you're looking at your x value of your vertex point. The y-intercept. So we're needing to find the y-intercept here. So in order to find the y-intercept, we know the x is 0. So we're going to plug into this function here. -2 times 0 minus 1 squared plus 9. So this is -1 squared right here. I need to do that. So that's +1. So -2 plus 9 is 7. So there's our y-intercept. So in vertex form, the y-intercept isn't as easy to find. So you have to plug in a 0 for x, because anytime we have a y-intercept, our x value is 0. The direction, we already said that it opens down because our A is negative. Okay, so those are the two forms that we're going to be looking at, standard form, vertex form of a quadratic. So there are ways that we can change our forms if we would like. So we're going to look at that on the back. We're going to be converting from vertex to standard and then standard to vertex. Now, the process that I use for vertex to standard is correct. I do this, but this converting from standard to vertex, I don't use this. I use the formula negative b over 2a to find the x value, which is your h of your vertex. So I'll look at an example. So converting from vertex to standard, I need to first write out x plus 2 twice because it says squared. I want it to be in standard form. And so I have minus 6. So I have to use FOIL because I'm multiplying. I would suggest multiplying these two first. That would be x squared plus 2x plus 2x plus 4. And then I need to combine these. That would make a 4x. And I need to distribute the 8. That's 8x squared plus 32x plus 32 minus 6. So that would give me 8x squared plus 32x plus 26. So if you're going from vertex to standard, you need to multiply it out. I would highly suggest doing this piece first, multiplying these two using FOIL, and then distribute your 8. And then don't forget about your k at the outside. So there's our standard form. So that's not too difficult. All right, so looking at 4, we're in standard form, we're going to go to vertex form. So on this one, this is how I do it. So we know that we have to find, in order to get it in vertex form, write down your vertex form. We need to find the h and the k, which is your vertex. Oh, let's go back up. Sorry. This one here, I would need to define the y-intercept. So the y-intercept, remember, is always your c in standard form. So your y-intercept would be 0, 26. Okay, so going back to the number 4. So I need to find the vertex. When we're in standard form, to find the vertex, I need to do negative b over 2a, and that will find the x value. So that would be negative 10 over 2 times your a is a negative 1. So negative 10 over a negative 2 equals 5. So there's the x value of the vertex. I want to find the y value. To find that, I'm just going to plug it in. So let's plug it back into this. I have a negative on the outside. I'm replacing x with 5. A common mistake is putting that negative inside parentheses, and that's not what we're doing because that's really a negative 1 in front. So that's going to be negative 25 because I square 5 and it's 25, but it's negative in front, plus 50 minus 16. So that's 25 minus 16, which would give me 9. So I found the x value right here, it's 5. I found the y value, which is 9. That is your h and k on the vertex form. So whenever I'm writing my vertex form, my a, look at your a was negative 1. and then x minus your h, which is your x value, so 5 squared, and then plus your k, so plus 9, because that's our y value. So you don't have to necessarily write the -1 in front, since you could just put negative in front. So there's our vertex form. We want to find the vertex, which was 5, 9. We found that, the x and y value of the vertex. We want the axis of symmetry. Remember, it's always x equals the x value of your vertex, which is 5. And then since our A is negative, remember our A is negative, it opens down. So if it opens down, oops. If it opens down, then that means we have a max at 5, 9. So we know the direction based on our A. It opens down, and then since our vertex is at the top, that's a max point. Okay, so if you go from standard to vertex form, you're going to use this formula to find the x value of the vertex, which is your h on vertex form, and then you'll plug in to find the y value, which is your k. That's the easiest way. If you want to use this method here, you're welcome to do that. Let me know if you have any questions.